Hello, welcome to another episode of Electronics Made Easy. Today we're going to talk about terminology. We're going to talk about speaking the same language. How do we communicate to others what we are seeing and interpreting? Just like doctors and lawyers, electronics industry has its own set of terms. Today we're going to look at a few of those basic terms so that we understand them and know what they mean. In the introduction, I showed you a few of the things that we've already covered. We talked about voltage and current, amperage. We also talked about resistance. We talked about power. Those are terms that we use a lot. We also talked about the terms that we measure those. The unit of measure for those terms is volt, amp, ohm, and watt. Those are also terms that we use a lot, almost every day. The first term we're going to talk about today is DC. It stands for direct current, and direct current is electrical current which flows consistently in one direction. It normally goes to a voltage level and consistently stays there at all times after it is turned on. The next term we're going to talk about is AC, which is alternating current. Alternating current is a type of electrical current in which the flow of electrons switches back and forth at regular intervals. Okay, if we take a look at the graphic here, we will see that the horizontal line represents time and the vertical line represents current. The line in the center denotes a zero current as well. Anything above that line is a positive current, anything below that line is a negative current, and AC goes through those cycles of positive and negative and back through the zero line at 180 degrees and 360 degrees in the cycle. You will hear the term circuit many times as we speak. But what is a circuit? A circuit must contain a source of power with a load and a return path to the power source. A closed loop must be maintained to form a complete circuit. As you can see, the current leaves on the hot. It proceeds to go through a load and then it returns. It must have the return path, otherwise it will not work. This is key to troubleshooting. That complete path is always necessary. Another term that is very often used is the term hot. And hot refers to the power source in a circuit. It's usually the plus in a DC circuit and the live or hot wire in an AC circuit. This is a complete circuit, you see. It has a source and then it has a means to turn off and on that source, and then it has a load, and then it has a return. So this would also be a complete circuit. Common refers to the return path in a circuit. Common is usually the minus in a DC circuit and the neutral in an AC circuit. The next term we're going to talk about is the term normally open, and it refers to contact switches and hundreds of other devices that conduct or do not conduct. And we refer to something that does not conduct current as a normally open contact. When it is open, it will not allow current to pass. And it's the NO is the abbreviation for normally open. And the normal condition means that the contact is de-energized state and is not affected by any outside influence. The other side of the normally open contact is the normally closed contact. And NC is the abbreviation for the normally closed contact. And current will pass through a normally closed contact. We've been through this on the video that we did on relays. If you have not seen that video, you probably should go back and watch it to be sure that you understand it. And again, the normal condition means that the circuit is in a de-energized state and is not affected by anything outside. And current will pass through a normally closed contact. There are several means that we use to describe whether a component is on or off, whether it conducts or doesn't conduct. Some of these are off and on, of course. We know what that means. 0 and 1, which is the equivalent in the digital world. Low and high also refers to the digital world. Open and closed and energized and de-energized refers to contacts, switches, push buttons, those sorts of things. So this is also an important part to remember. We've been over this before, however, I think it is well worth revisiting. It's how we describe a circuit when we are working with it. And we're going to start with the term if, and that is typically the beginning of the rung and usually means the power source. Then means the end of the rung, and that typically means what you are going to be controlling. There is a device that is turned off or on at the end of the circuit. And means there is a series component in a rung. By series we mean one must be on before the next one, and so on. Or means that it is a parallel component in a rung, which means that if any one of those components are turned on, it will conduct through that circuit. And not typically means that the component is in its de-energized state. Those are very important when you're describing your work to someone else, trying to figure out a problem on the phone, things like that. It's very important to know those. Other people will understand you if you use these terms. We're going to talk about the terms that we use to describe numbers. We use the metric system to do that in the electronics field. Many of these you have heard before, I'm sure, but the most typical ones you're going to hear, there are 6 that are most typical. And we will start with the very smallest, which is nano, which is 10 to the minus 9. Then we have micro, which is 10 to the minus 6. And then we have milli, which is 10 to the minus 3. We will use those to describe small measurements. Now, when we get to the larger measurements, we use terms like kilo, which is 10 to the 3rd. We use mega, which is 10 to the 6th. And we use giga, which is 10 to the 9th power. Those are going to be important when you're describing numbers, and we work with very small numbers and very large numbers. This chart shows everything from 10 to the plus 24th to 10 to the negative 24th. Most of those we don't use. We normally use the ones that I just referred to. Those 6 are very important. So please try to keep those in your mind as we go through this. The next 3 charts are just valuable information that I'm sure you can use. So just kind of read them over and keep them in mind. You can probably if you need these, we can probably supply them to you. Just send us a message and we will try to get them to you.